denser. It is mass denser or density by mass. Density by mass. Okay. Or mass density. Or mass according to my means density. It does not mean that an object is, if it is denser, does not mean that it is optically denser also. So here the word we need to use here is that optically denser and optically rare. Why? Because if I'm saying that if an object is moving, or sorry, if an object, if I'm saying that, let's suppose if a ray is traveling from one medium to another medium, okay, got it? If a ray is traveling from one medium to another mediums and it bends, let it bends towards the normal, let it bends towards the normal, okay? It bends towards the normal and then again. So actually, this is the normal line and this is, here is the normal line, okay? This is the normal and this is also normal. So it is bending. It might be going to this way, but it bends towards the normal. Okay, so when a light travels, lights bend towards the normal, it is considered to be as denser. Okay, so comparison to this one, it is rarer, and it is denser. And here you see that light is again, light seem to move like this way, but here it moves away from the normal. So it is again rarer. Okay, now explaining again, what I want to say that if an object is like for example, you see that a glass, comparison with glass and air, which is denser? Which one is denser? Tell me.
Glass is denser.
Glass is denser. Okay. Now, according, if I'm just taking the example of turpentine and water. Turpentine and water. Which you think is more denser? Turpentine and dense. And turpentine is actually kerosene. Kerosene. Okay. Which you think is more denser? So accordingly, if you see that, if you see like this one, so you will see that when you have a mixtures of turpentine and water, you will see that water will be at the bottom. This is water, and the turpentine will be at the top. And the turpentine will be, the oils come at the top. What does this indicate? What does this indicate? This is turpentine. Right? This is turpentine.
It indicates that the water is heavier or denser than kerosene.
Yes, yes. But actually optically denser means that when a light pass from one medium to another medium, okay, so it should bend towards the normal. If it bend towards the normal, if a light is passing like this way, and if bends towards the normal, then it is considered, the medium is considered to be as denser, optically denser. So what we experimentally see that this is water, this is turpentine. Okay, this is turpentine. We see that this is turpentine and this is water. Okay, you see that in according to the mass density, water is more denser. Water is, according to mass density, water is more denser. Why? Water is more denser because water, you see that water means lies on the bottom or at the bottoms, and the oil come over it. Okay, oils is coming over it. So in this case, we see that the turpentine or kerosene is less denser than water. Okay, is that clear? Is that clear?
Yes, sir.
But when we pass, let us have an example of, this is water. This is water. Okay. Let's suppose if this is water and if this is turpentine or kerosene. So if I'm passing, let's suppose if I'm passing, this one is a ray that is passing from this turpentine. So when it enters the water, should it bend away from the normal or towards the normal?
It should bend towards the normal.
Towards the normal. But experimentally it is observed that when the light is passing from turpentine to water, then it bends away from the normal. It bends away from the normal. Okay. So so now we can compare here. We can say that, let's suppose this is normal line. This is the normal line, normal, and it is bending away from the normal. So when a ray is bent away from the normal, so it is considered to be the rarer medium. Is considered to be a rarer, and this will be considered as dense. So it is not necessary that if an object or if a substance is a mass density, mass wala jo denser hota hai. If an object is mass density, means it is more denser according to the mass, it is not necessary that it will be denser or optically denser. Okay. So if I am saying that optically denser means that when a ray passes from one medium to another medium, the ray should bend towards the normal. So here you see that, or you can trace the path in backward direction also. If the ray is passing like this way, then it should move towards this one, but it bends towards the normal. It bends towards the normal. Ashid, you understood? Ashid,
Yes.
you understood? So if I'm saying that if a ray is passing from one medium to another medium and it bends away from the normal, then if it bends away from the normal, then it is a denser, then it is a rarer medium. So this one is the rarer, it is bending away from the normal. The ray should come like this way, but it is bending away from the normal. Okay. And okay, so comparing this one is denser, this one is rarer. However, we see that experimentally, we see that the mass density of water is more than the mass density of water is more than turpentine, okay, but turpentine is optically denser than water. Okay, understood? Got it? Turpentine is optically denser. And in mass density, water is more dense. But optically denser means a ray should pass, when a ray is passed through it, then it should bend towards the normal. Got it? So here, turpentine is more denser than water. But optically, turpentine is more denser than water. Okay? But according to the mass density, water is more denser. Got it? Got my point?
Yes, sir.
There are two types of denser medium. One is mass density, another is optically denser. You understood the difference? Mass density,
Yes.
mass denser or mass density, and optical density. These are the two different terms. They are not the same. Okay. If an object is denser, is having more mass density, it may act as a rarer medium, like in water, in case of water and turpentine. Got it?
Yes, sir.
So please note it down. You have noted this one? Light should bend away from up to here. I think you have noted.
No, sir. We have not noted.
You have not noted. Okay, note it down. When you done, please let me know.
Done, sir.
Okay. Now moving to the law of reflection. Let's move to the law of refraction. As we have studied the law of reflection, similar are the laws of refraction. So the first law of refraction says that the incident ray, the refracted ray, and the normal lies on the same plane. To explain you what is the first law of the first law of refraction state. The first law of refraction state that the incident ray, let's suppose if a light is traveling from one medium to another medium. Okay. And this is x-axis. This is x-axis. This one is y-axis. This one is z-axis. Okay. So may I know that the face of this one? May I know the face of this one? Face, the axis of this, or may I know the face? In which plane this face lies? In which plane does this face lie?
In the YZ plane.
In the YZ plane. In YZ. Okay, Y. This is Y, and this one is Z. So what does it says? Let me explain you here. The first law of refraction states that the incident ray, the incident ray, the incident ray, the refracted ray, and the normal lies on the same plane, lies on the same. You understood? Lies on the same plane. Okay. So what does this it says? It simply statement means that if it's suppose if I'm saying that a ray is entering, let's suppose a ray is entering on this plane, that is the top plane. Okay. In this mirror, or this is a glass slab. Let's imagine this is a glass slab. Okay, and light is entering. A light is entering. So a ray of light is entering. Let's suppose. Okay. So can you imagine the plane of this one? If I move, let's suppose this is a screen. Let me explain you one more time. Let's suppose this is a screen that I'm having in front of your, and it is made up of only two dimensions. A screen can only be made of two dimensions, for example. So if I'm saying that this is the x-axis and this one is the y-axis, this one is x, this is y. So if I draw any line on this axis, on this one, so it will lie in xy plane, yz plane, or zx plane. Tell me, in which plane it will lie?
YX plane.
Yeah, it will be yx plane, xy plane. Why? Because z is inside, and if a ray is passing into the screen and coming out of the screen, then it will be a z plane. But if I am drawing, there is no line that is passing into the screen. They are just on the screen. Yeah, over the screen. They are touched. Similarly, if I am saying that this one is the top part of the glass slab, okay, this one is the top part of the glass slab, and you see here like this look. Okay, so if a ray is coming, then it is traveling downward. You see that it is traveling downward. Here you see you can trace the particles also. Let's suppose this particle is here. Now it come here, now it come here, now it come here. Okay, so you see that the position of the particle is coming down, means it is traveling along the y-axis. Coming down means up and down is y-axis. Okay, up and down is y-axis, and it is also moving from this side to this side. You see, the particle was here from here, then it comes to here, then it come here. So you see that particle is also moving to this side. So actually this ray is traveling. Actually this ray is traveling in y and x plane. Yeah, xy plane. Okay, we can consider this one. Okay, this ray is traveling in xy plane. Xy plane. Now moving. Similarly, this ray will bend. If this ray bends, then it will also move into xy plane. It cannot move into the or it cannot move along the z-axis. It cannot move along the z-axis. It cannot move along the z-axis. It cannot come out of the screen or it cannot go into the screen. Okay. If it is traveling, then it will bend into this manner, and the normal will also lies in xy plane. Here you see that x-axis for this one is 0. Why? Because this one is traveling along the y-axis. Okay, so they are all going to lie on the same plane. Similarly, if a ray is traveling, let's suppose if a ray is entering, let me explain you again. If a ray is traveling from this way, let's suppose this way, okay, into the screen. Let's suppose this is entering into the screen. So you see the particle trace, that particle is moving into the screen means z, and it is moving along the x-axis also. You see that this is moving along the x-axis. This particle is here, then it comes to this side, then it comes to this side, then it's come to this side. So it is means left and right is actually x-axis. So this is moving in z-axis. So you see that if it bends or if it lies, then it will again go into the screen. It cannot come up. It cannot move upside and downside. It cannot come into the y-axis. So this is a simple phenomena that if a ray lies in xy plane, then it will bend in xy plane. And the normal will also lie in xy. If a ray is moving in zx plane, then it will bend in zx plane. It cannot come into the y plane. Okay, got it? Got it? Understood?
Yes, sir.
If a ray is traveling in xy plane, then if it bends, then it will bend in xy plane. Okay, if a ray is touching, means if a ray is touching this screen, let's suppose this is the screen I am having, and suppose, okay, if a ray is touching, so this is a simple way that you can explain or that you can understood by this method, by these projections. Okay, you can understood by with this one. So if a ray is traveling in xy plane, then it will bend in xy plane. It cannot move upward and downward. If a ray is moving into the screen, so it cannot move upside to this. So this is the simple way that the incident ray, the reflected ray, and the normal lie on the same plane. Got it? Got it? Got it?
Yes, sir.
And the second law or the of this one, that we can say that it is also called Snell's law. It is also called Snell's law. Snell's law. That it say that the angle of incidence. So, for example, if this is a glass slab and a ray is passing through it, okay, this is the normal, this is the incident ray, and this is, if it bends, it is the refracted ray. This one is the refracted ray. Now, this one, this angle is incident angle, and this angle is the refracted angle. So it say that sine I upon sine R is equal to constant, and that is noted by mu, that is called refractive index. Refractive index. Let me explain you one more time. What does it say? It says that simply that sine I by sine R, the ratio of sine angle of incidence to the sine angle of refraction, is constant for a particular medium. If it, for example, if I'm saying that for example, if I'm having this 30-degree angle, okay, and this one is having let's 20-degree. So if I increase this length, if I increase this angle, then this angle will adjust accordingly, that the ratio of their values will remain constant. Okay, for a particular medium, the ratio of sine I to the sine R is constant. For different medium, the ratio may change. For example, if I'm saying this sine I by sine R of glass is 1.5. So if I'm saying that this is sine I by sine R of water will be 1.33, and that is sine I by sine R of diamond will be 2.42. So the value will change. If a medium with a medium change, then the ratio will change. But for a particular glass, if you change the value of I, then it will remain constant. For example, if you have this value, let's suppose this is 30, then this value will adjust accordingly. If you make this angle, if you increase this angle, then the ray will also increase, and the value will adjust in such a way that when you put some angle here, then the ray will the refracted ray will make a such angle that the ratio of this value and this value will be constant. Always it remain constant. Got it?
Yes,
It
sir.
will always become 1.5. It will not change. So this is called Snell's law, and this is the second law of refraction. Okay. So note it down. Note it down. Note it down. So no, this is the first law of refraction, and the second law was that I have explained. That is the incident ray, the refracted ray, and the normal line of the same. So please note it down. The first law of refraction is the Snell's law, and that is sine I by sine R is equals to constant, and that is called refractive index. And draw this one, please. And let me explain you one more thing here, that this angle is angle of incidence, this angle is angle of refraction. Again, this angle is also, because this, you can imagine that these are the two parallel lines. Okay. And here, this and this angle will act as equal angle. Why? Because it is forming Z and this is co-integral angles. So this one is equals to R, and this one is E, that is emergent angle. E, angle of emergence. Okay, got it? Got it? So please note it down and make this down. The incident. First law of refraction said that the sine angle of incidence, sine, the ratio of sine angle of incidence to sine angle of refraction is constant. You writing?
Yes, sir. Do we have to note the diagram on the right hand side?
On the right hand side, yes. Make it.
Emergent ray and
Yeah. Please make it. Angle I is always equals to angle E. Means in an experiment, it is always true that angle I must be equals to angle E. Incident ray will be equals to emergent ray. Okay, should be equals to emergent ray. Done?
Yes, sir.
Is there anyone who is still writing? Ashit and Ammar, are you still writing? Ashit, are you there in the class?
Sorry, I'm writing someone.
You are still writing. I didn't understand you. Ashit, are you getting my voice? Take it. Refractive index is unitless quantity. Why? Because it is the ratio of same thing. Sine I by sine R, that is also unitless. So if I'm having some velocity by velocity, let's suppose if I'm having a ratio of velocity by velocity, so that will be equals to meter per second divided by meter per second, 30 meter per second, 40 meter per second. So meter second will cancel out. So if we have any physical quantity that is going to have the same dimensional unit, that is meter per second, that is meter per second, or if it is meter, or if it is something, anything that is having the same in the numerator and denominator, the same unit. So that unit will be considered as dimensionless or unitless quantity. Got it? The refractive index is unitless quantity. It does not have any unit. Okay. Like the mass has kilograms, speed has meter per second. Okay. Force is Newton. So that's why so here refractive index is not going to have any special unit. Okay. It is unitless quantity. Got my point? Understood?
Yes, sir. Yes, sir. Done, sir. We have noted.
Okay. Is there anyone who is still writing?
No,
Ammar, done?
yes.
Okay. Let's move. Let me explain you one thing. So second law of refraction is very important. That is called Snell's law. Snell's law. And we need to understand here that sine I by sine R is constant. That is equals to mu. Okay. That is equals to mu, and it is represented, and it is, we call it refractive index. Refractive index. Okay. So if I'm saying that, let's suppose if I'm having this angle of incidence, that this is the angle of incidence. Okay. Okay. Let me explain you. And this one is the angle of refraction. Okay. This is I, and this one is its refractive index. Sorry, angle of refraction is R. So let's suppose if I pass the ray from this one, if I increases the angle of incidence, should the angle of refraction increases or decreases? Will the angle of refraction increases or decreases? This type of knowledge is very important to solve the MCQ, multiple choice question, and to get the estimation of the answers. Tell me, Abir, any idea? If I increases the value of I, will the value of R increases or decreases?
It will also increase.
Yeah, it will also increase. The ray will bend, but it will also increase. Okay, the angle of refraction will also increase. Why? Let me explain it. Why? The value of sine, and the value of sine I by sine R, let me explain you. I is angle of incidence. And have you studied the trigonometry in mathematics?
Yes, sir.
Everybody in the class? There are the three values, that is sine 0, sine 30, then sine 45, then sine 60, and then sine 90. You see that this is sine 0 is 0, sine 30 is half, sine 45 is root 1 by root 2, sine 60 is root 3 by 2, and that is 1. This is 1, this is 0.5. When you calculate this one be greater than 0.5. Okay, this value is also going to be greater than this value. And finally, this one is 1. Means the minimum value of sine, is 0, and the maximum value of sine, here it can be negative also, but if I'm saying that for the positive value, the sine values lie from 0 to 1. Got it? It does not increase its value from 1. Okay, got it?
Yes, sir.
Understood? Now, if I'm saying, let me explain. If I'm saying sine I by sine R for glass is 1.5. Okay, 1.5. For glass is 1.5. Now, if I'm saying that this is sine 30. Okay, sine 30. Then what should be the value of sine R? Whatever the values is, if I increases the numerator, for example, let me explain you one more time, this one. For example, if I'm having the value of something is 1.5. So if I'm saying that if I increases the numerator, let's suppose if I'm saying that this is 10 by 1.5, I have to write. So that is 15 by 7, 1.5. So let's have any value. Okay, that if I'm having 30 by 10, let's for example, this value is 3. For example, this value is 3. Okay. Now, if I need to make that now, if I need when you cut it, you will get 3. But if I make this one 60, then what should be the value of this one?
20.
In order to make it 3, yeah, it should be 30. If I made it 120, then it should be 40. So in order to keep this value constant, if I increase the value of numerator, then the denominator will also increase to keep this value. For example, if this is 30 by 10 gives 3, and this 3 is constant for every glass, or for every we can say that for every medium there is a different values of refractive index, but for a particular medium it remain always constant. For example, glass, the ratio of sine I by sine R will be always constant, that is 1.5. That is always constant. Whatever the value you are taking I, it will be always constant. The R will accordingly shift. So if I increase the numerator, the denominator will all automatically increase in order to keep this value constant. Got it? Now you understood my point? What I want to say? That sine I by sine R, if I increase the value of I, then R will automatically increase. And this will help us. For example, let me give you the question related to this one, that how the examination, the question is being asked. So let me wait a minute. Let me find out the question. Okay. There are experimentally types questions will be asked in the examination. Okay. I will send you the homework. Okay. For example, this one. Take this medium. This medium is A and this medium is B. Okay. A light enters from medium A to medium B. Light is entering from medium A to medium B. The refractive index of B relative to A. Okay. Okay. Let me explain you one more thing here. Is that when a light is traveling from rarer medium to denser medium, if the light is traveling from rarer medium to denser medium. to denser medium. Okay. Then the ratio of sin I by sin R, जिसको हम लोग we called it refractive index. Refractive index. The ratio of sin I by sin R is greater than unity. Unity means 1. Okay, 1. And it should be greater than. And the light is traveling from rare medium to denser medium, it should be greater than 1, and vice versa. If it is traveling from rarer from denser to rarer, it should bend, or we can say that it is going to have the refractive index lesser than 1. Let me explain you why. Let's suppose if I am having a numerator greater than a denominator, for example 3 by 2, for example 5 by 6, for example 7 by 5, for example 4 by 3. Every time the numerator is greater than denominator. Okay, you will find whatever the value come, it will be greater than 1. Understood? Understood? Hashit, you understood? Abir?
Yes.
Okay. Yeah, why not? If I'm saying that whenever you are going to have a numerator greater than denominator, you will always be going to have a value. In this case, this is 5 by 6, 6 by 5. 6 by 5. Numerator is greater than denominator, numerator is greater than denominator, numerator is greater than denominator, numerator is greater than denominator. You see that every time, whatever the value divide, you will get the value which is greater than 1. This is value is greater than 1, this value is greater than 1, this value is greater than 1, this value is also greater than 1. Got it? Got it? Now look at this. What is going to happen? When a light is traveling from rarer to denser medium, in that case, you will find that I and R, you will find that when a light travels from rarer to denser medium, okay,
So
then angle
the refractive index will be bigger than 1.
Is be greater than. Why? Because I is here. I will be always greater than angle R, angle of refraction. Here, when a light is traveling from rarer to denser medium, the angle of incidence will be more than angle of refraction because light bend towards the normal. Rarer to denser, light bend towards the normal, so the value of R will decreases. And you know that the in term of sine, more the theta, more will be the value. Means sine 0, you see that is 0. Sine 30, you see that is 1 by 2, and so on. Up to 90, the value of sine increases. We can say that if the theta increases, the value also increases. Whatever the value of theta is. If theta is more will be the value. Got it? So if I'm saying that sine I by sine R, whatever the value is, if I'm saying I is greater than R, so the whole value of sine will be greater than the value of R, this whole value. What if I is more, then the value of sine I will be more. If R is less, then the whole value of sine R will be less. So in this case, numerator will be greater than denominator. You understood? Numerator will be greater than denominator. So whenever the numerator is greater than denominator, the value will be greater than 1. Got it? Got it, Abir? Understood? Others? Understood what I want to say here? That sine I, if I is greater than R, then whatever the value of R is, okay, if I is more, then whole sine I will be more. If R is less, then whole sine R will be less. Then simply, if numerator is greater than denominator, the value will be more than 1. Okay, and it is and the vice versa of this one is also true. For example, if I'm having a ray is moving from denser to rarer medium, it is denser, and it bends away from the normal to rarer medium. So here you see this is I, and this one is R. Okay, so in this case, when the I is smaller than R, the sine I will be smaller than sine R. Sine r. So the ratio sine I by sine r in this case will be lesser than 1. Why? Because this is more value, this is less value. So if I'm having 3 by 4, if I'm having 5 by 6, if I'm having 7 by 9, if I'm having 2 by 3, if the numerator is smaller, then the value will be less than 1. Got it? Less than 1. It will be in decimals. Got it? Less than 1. Okay, got it? So tell me what should be the correct answer for this question. Tell me what should be the correct answer for question number 5.
It should be greater than unity.
It should be greater than.
Unity.
Why? Why? Because when you measure the angle from this one, you see this is angle I and this one is angle R. This one is angle R. So you see I is more than R. If I is more than R, then it will be greater than unity. Okay, tell me if the ray is traveling from denser medium to rarer medium or rarer medium to denser medium. Tell me if the ray is traveling from. I'm asking that if the ray is traveling from rarer to denser in this figure or denser to rarer.
Rare dense.
From rarer to denser.
Yes, it is moving from rarer because this one I is more and R is less. If R is less, then it is denser. Okay, rarer to denser. Very good. Very good. Okay. So here I am having this value. Okay, tell me. Let's show the diagram for this one. Medium A to medium B. The refractive index of medium A relative to medium B will be. Tell me. A ray of light has traveled from medium A to medium B. The refractive index for this one. You see that light is traveling from this one to this one. Okay. The relative refractive index of medium B relative to medium A. What should be the means you have to write the value of sine I by sine R. And light is traveling this path. This path is being traced by light. So sine I. What is I? First tell me what is the value of I?
60 degree.
60 degree. And what is the value of R?
45.
45 degree. Got it? 45 degree. So you can write it that is sine I by sine R is equals to sine 60 by sine 45. The value of sine 60 is root 3 by 2. And the value of sine 45 is 1 by root. So you know that this numerator is being dividing this one or is being divided by this one. Means you can write it this 3 by 2. Sorry, root 3 by 2 is being divided by 1 by root 2. Can you write it like this way?
So we have to keep it in multiplication with the
Yes,
reciprocal.
then this will be 3 by 2. Root 3 by 2 into root 2 by 1. So this will be root 6 by 2. Okay. Or you can cut it. You know that this can be written as root 3 into root 2 upon 2 can be written as root 2 into root 2. This is 2. 2 into 1 means 2. So this is 2. Now you cut it, you will get root 3 by 2. Root 3 by root 2. Got it? Got it?
Yes, sir.
So have you noted the values of sine 30 and sine 0? Please note it down. Sine 0 is 0. Sine 0 is 0. Sine 30 is 1 by 2. Sine 45 is 1 by root 2. Sine 60 is root 3 by 2. And sine 90 is 1. Please note it down. Ridwan, where were you? Why are you late? Ridwan, are you there? Try to join on time if you want to learn something more in an appropriate manner. This is very important for every student that okay, that you must join on time to understand, to get some knowledge in proper manner. Otherwise, there's no benefit for this class. Okay. Done.
Done, sir.
So, what was the answer for this one? Is what was the answer? That is root 3 by root 2. So this one is root 3 by root 2. A is the correct option. You understood?
Yes, sir.
Okay. So now moving to this one, let's have some more question regarding to this point of view. Okay, tell me which one is the correct path in question number 14. You see 14, question number 14, which one is the correct one in figure 10.5? Which one is correct? A, B, C, D. Which one is correct?
B is correct.
B is correct. Why C is incorrect?
Because if you extend the incident ray, it will be parallel to the emergent ray.
Yeah, you see that, because you see that it is not bending here, and moreover it is bending towards the normal when a ray is coming from denser to rarer. And C is rare, in this region is rare, so it must bend away from the normal,
Away from
like
the
this.
normal.
But it is bending to. Yeah, so B is correct. Very good. B is correct. You are given water, mustard oil, glycerin, and kerosene. In which medium? In which of these medium a ray of light is obliquely at some angle would bend the most? In which it will bend most? So which one is more denser? It will bend most. But you think here that water, glycerin, oil, and kerosene. Okay, let it be, because you have not studied the chart, so I'm getting it. Let me give you some important question. So, for example, so let's study further so that we can understand the other parts of this. Okay. So let's discuss the other part of this. Now, the refractive index is also, you see that refractive index is sin I by sin R, that is mu. But refractive index is also means you can say that the speed of the light in one medium means it is also the ratio of the speed of light in one medium to the speed of light in second. Got it? So there are the two types of refractive index. One is the relative refractive index, relative. Another one is absolute. Another one is absolute. Okay. Now you got it. So you see here that there are two types of refractive index. Hamid, please wait for 1 minute. Okay, one or 2 minutes. Are you there? Okay. So there are two types of refractive index. One is the relative refractive index, and another one is the absolute refractive index. What is the difference between these two? That if the first medium is fixed, that is air or vacuum, then the type of refractive index becomes the absolute refractive index. Okay, got it? And since you see that the speed of light is maximum in vacuum, so this, if the numerator is maximum, so whatever the value is coming in the denominator, if the numerator is maximum, so the numerator is going to have the value which is lesser than the numerator. So you will always get, in such condition, you will always get the maximum speed. Okay, understood? Understood? Are you there?
Sir, can you tell one more time?
Hmm?
Sir, can you explain one more time?
Yes, why not? I can explain you this one more time. That absolute
No,
refractive
in the
index.
questions,
Yes.
so in the questions, will they ask us what is the relative refractive index, like that?
Yeah. They may ask you absolute and relative refractive index. So example, this question is given to you here. Let me explain you that what is that this one is the find out the absolute refractive index and find out the relative refractive index. Sometimes the relative is given, absolute is being asked. Sometimes absolute is given, relative is being asked. So you must understand that what is the relative and what is the difference between the relative and the absolute. Absolute refractive index, they will not give you this medium because it is mandatory that you have to keep the first medium as air or vacuum. Okay, that is the speed of light in air, that is 3 raised to the power, 3 into 10 raised to the power 8, okay, meter per second. 3 into 10 raised to the power 8 meter per second, okay. But here you see that if the first medium is the maximum, the highest speed of light is in vacuum, that is 10 raised to the power 8. So whatever the value is in the numerator, it will be lesser than the, so whatever the value is in the denominator, it will be always lesser than the numerator. So in this case, you will always find the numerator is greater than the denominator. For example, if you are having instead of vacuum, everything in the universe is going to have, in that medium, the light is going to have lesser speed. So if it is glass, if it is water, if it is anything, this numerator is going to have the value lesser than the, this denominator is going to have the value lesser than the numerator. So when the numerator is greater than the denominator, the value will be always greater than 1. So absolute refractive index is never less than 1. It will be always greater than 1. Got it? Got it? So
Yes,
if it is
sir.
given that 1.33, 1.45, so it means generally it is given absolute refractive index. If it is more than 1, it is absolute refractive index. Understood?
Yes, sir.
Okay. So beta, that's all. Please try to join on time because I was waiting. This is 20 to 20 minutes or 15 minutes you have wasted. So please, it might request that this chapter is very, very important, not for the only 10th standard, but also it is a base for the 12th standard optics. Okay. So please try to come on time. I want to teach you in a very good and appropriate manner. Okay. So that you may understand each and every concept that is going to come in your examinations. And I'm just building